In March 2026, Elon Musk announced a $25 billion compound in Texas called TERAFAB. He described the facility as a necessary requirement for the growth of a galactic civilization. Humanity is currently classified as a Type 0 civilization. We have the intent to colonize Mars, but we lack the raw computing power required to manage the massive automation needed for off-world construction. The world currently produces 20 gigawatts of AI computing power annually. Musk's space goals require 1 terawatt, 50 times more. Because traditional supply chains can't scale, Musk is building a Texas megafactory to bring chip design, fabrication, and testing into a single high-speed loop. Before humans can expand into the solar system, we must first clear this computational hurdle. Crossing this threshold is the prerequisite for any large-scale physical operations off-planet. By bringing both chip design and fabrication into the same facility, SpaceX and Tesla can avoid the slow turnaround times of the global semiconductor market. This allows for rapid iteration, fixing design flaws in days rather than months. TeraFab will produce 2 distinct classes of silicon. The first are edge inference chips, which will act as the local brains for terrestrial robots. The majority, however, will be non-terrestrial chips, hardware designed to operate in the high radiation environment of space. But even with a steady supply of chips, there is still a physical bottleneck. Lifting a terawatt of compute hardware and the machines it powers into orbit requires a delivery system capable of moving massive payloads at a lower cost. This is the role of Starship version 3. Standing over 124 meters tall, this version utilizes Raptor 3 engines that generate 50% more thrust than previous models, enabling a payload capacity of up to 200 tons. The architecture relies on an orbital refill strategy. A main ship launches to low Earth orbit, where a series of tanker flights meet it to refill its propellant tanks, providing the energy needed for the long transit to Mars. If TeraFab provides the intelligence, Starship V3 is the transport system. Together, they make the construction of off-world megastructures economically viable for the first time. Musk's strategy is to have a functioning colony waiting on the surface before the first astronauts arrive, with a target date around 2030. To meet that deadline, the first Starships will land fleets of heavy 3D printers and autonomous Optimus robots on the Martian and lunar surfaces. These machines will process regolith, the local planetary dust, using it as raw material to manufacture concrete-strength walls and oxygen generation plants before any humans step off a ship. Using robotic builders that do not require oxygen or food shifts the primary challenge of colonization. It moves the focus away from keeping humans alive during construction toward the logistics of raw mass delivery. There is one final constraint: energy. Mars receives only 43% of the solar intensity that Earth does, which is not enough to power a massive industrial fabrication hub on the surface. The solution is to scale the Starlink concept into a Dyson swarm, millions of solar-collecting satellites positioned in a direct orbit around the Sun. These satellites capture 100% of the unfiltered solar energy available in space. They then beam that power wirelessly via high-intensity lasers or microwaves to receiver stations on the surfaces of Earth and Mars. To avoid the cost of launching from Earth, future lunar factories will use moon-based resources to manufacture these solar harvesters directly in low gravity. Establishing this wireless solar energy grid addresses the final absolute physical constraint of permanent settlement: energy scarcity. These 3 technologies, compute, transport, and energy, interlock into a single autonomous system. The TeraFab chips provide the logic, Starship provides the movement, and the Dyson swarm provides the fuel. This scale of energy capture is the hallmark of a Type 2 civilization, a species harnessing the full power of its host star. Currently, humanity is restricted by the finite resources of a single planet. Our total energy and compute capacity are limited by what we manage within our own atmosphere. Musk's integrated strategy is designed to move the species past those planetary limits. If these systems can scale, they provide the infrastructure required to finally direct the full power of the Sun to support expansion into the solar system.